For decades, space exploration has represented humanity's highest ambitions, an effort to go beyond our limits, to reach distant worlds, and to seek answers among the stars. It's a mission often celebrated as noble and unifying, a technological triumph that transcends borders and politics. But as rockets rise and satellites circle the Earth, a quieter consequence is taking shape far below, one rooted not in innovation, but in destruction. While we search for new worlds, we may be destroying the only one we've ever truly had. Because behind the glory of every rocket launch, there's a cost that's often overlooked: the land we clear, the ecosystems we damage, and the wildlife we displace in the name of reaching space. And that raises a pressing question: is space exploration slowly, silently killing nature? The foundation of every space mission begins right here on Earth, and specifically on the ground. Spaceports, launch pads, fueling stations, control centers, and tracking installations all require vast amounts of land, infrastructure, and energy to function. To ensure safety and efficiency, these facilities are often built in remote, undeveloped areas where human population is low, but where natural ecosystems are still rich, delicate, and often irreplaceable. Take the European Space Agency's Guiana Space Center, for example, located in the tropical rainforest of French Guiana, one of the most biodiverse regions in the world. Though officials argue that the base operates under sustainable protocols, critics say the long-term effects on local habitats, soil integrity, and wildlife migration patterns remain underreported and understudied. Likewise, India's Sriharikota launch facility is situated on a coastal island that was once home to thick mangrove forests and thriving marine ecosystems. In the name of science and national pride, these natural environments have been gradually replaced by concrete, tarmac, and heavy machinery, leading to erosion, habitat fragmentation, and ecological imbalance. In the United States, SpaceX's Boca Chica launch site in Texas has become a lightning rod for environmental debate. Built along a fragile coastal zone, the site borders wildlife refuges and nesting grounds for endangered species such as the Kemp's Ridley sea turtle. Each test launch, explosion, and expansion project draws concern from conservationists, who warn that the ecosystem may not survive repeated disturbances over time. The consequences of space development extend beyond land use. Rocket launches themselves generate large amounts of exhaust gases, releasing chemicals like carbon dioxide, aluminum oxide, hydrogen chloride, and other toxic byproducts into the atmosphere. Some of these substances contribute to ozone layer depletion, disrupt local weather patterns, and pollute the air, soil, and water around launch sites. Even solid rocket fuels, which are commonly used in modern boosters, produce corrosive compounds that linger long after a mission ends. In some cases, spent rocket stages fall back to Earth, either in oceans or remote wilderness, leaving behind debris and chemical residues that contaminate delicate ecosystems without any cleanup plan in place. Space advocates often argue that, compared to major polluting industries like oil, fashion, or transportation, the environmental footprint of the space sector is relatively small. And while it's true that space launches number in the hundreds annually, far less than the billions of cars on the road, this argument overlooks the rapid expansion of space activity, especially from private companies. Today, more nations and corporations are building spaceports than ever before, and the number of rocket launches is increasing exponentially. Programs like Starlink, with plans to deploy over 40,000 satellites, require continuous launch activity on a scale never seen before. Each of those launches requires fuel, logistics, transport, construction, and, inevitably, land. That means more forests cleared, more wildlife pushed out, and more noise and light pollution in areas once left in peace. In Australia's Northern Territory, proposals for new spaceports threaten Aboriginal lands, cultural heritage sites, and vast stretches of untouched wilderness. Local communities have voiced concerns over the impact on native flora and fauna, as well as the lack of transparent environmental impact assessments. Meanwhile, in Scotland's Sutherland region, peatlands, some of the world's most efficient carbon sinks, are being cleared to make way for space facilities. These peatlands are critical in the fight against climate change, storing vast amounts of carbon that would otherwise enter the atmosphere. Destroying them to build launch sites seems not only ironic, but dangerously short-sighted. So what can we do about it? First, we must shift our thinking. Space exploration and environmental protection are not opposing goals, but intertwined responsibilities. If our pursuit of the stars leads to the degradation of Earth, then we are not progressing, we're regressing. We must implement and enforce global environmental standards for all spaceport development, regardless of whether the project is public or private. Environmental impact assessments must be rigorous, transparent, and updated regularly, especially as climate patterns shift and ecosystems evolve. Space agencies and corporations must be held accountable for their ecological footprints, not just in words, but in action. This means investing in habitat restoration, funding biodiversity protection, and offsetting carbon emissions through verified, science-based programs. We must also rethink where we build. Instead of clearing virgin forest or wetlands, we should prioritize the use of already altered lands, abandoned military bases, decommissioned airfields, or even offshore floating platforms that reduce stress on terrestrial ecosystems. Most importantly, we need to invest in cleaner propulsion systems, rocket fuels that emit fewer toxins, engines that operate more efficiently, and long-term plans for green space technology. If we can engineer machines to land on Mars, we can engineer launch systems that don't destroy Earth in the process. Because the brutal truth is this: Earth is not just a launch pad, it's the only living world we know. The only planet with rainforests that breathe for us. With coral reefs that host millions of species. With birdsong at dawn and the rhythmic pulse of ocean waves. We are not leaving Earth behind, we are still deeply, biologically tied to it. And if we destroy it in the process of exploring space, we may find that nothing out there can ever replace what we lost down here. So before we clear one more tree, before we pour one more foundation into the soil, let's ask ourselves, are we building for the future? Or are we just repeating the mistakes of the past, on a cosmic scale?